All right, the homework, the football dilemma. Um, so let's just kind of go right down to this. So the Navy quarterback is standing at the point 32-4. So 32, let's see, each square represents 2 yards. So 32-4 would be approximately right there. And it says every quarter of a second the ball moves 4 yards west and 3 yards south. So we want to graph the progress on the field. So 4 yards to the west would be 2 spaces to the left, and 3 yards south would be 1.5 of those spaces. So that's like right there. I think that looks right. And then 4 yards to the left is 2 more spaces. 3 more south is going to be right about there. 4 yards, 3 yards, 4 yards, 3 yards, 4, 3, 4, 3. Let's see, 4, 3, 4, 3. So that looks right. All right. And then the receiver, starts at 26, -14. So 26, 1, 2, 3, -14. 2, 4, 6, 8, 10, 12, 14. Looks like it's right about there. Hopefully that's correct. And let's see, every quarter of a second he moves 3 yards 3 yards west and 1 yard north. So 3 yards west is 1.5 spaces, 1/2 a space north. Yeah, that looks right. 1.5 spaces, 1/2 a space north. 1.5, 1/2 a space north. 1.5, 1/2 a space north. 1.5, 1/2 a space north. This is harder to do with these half spaces than I would have thought, but clearly from what I've just done there, you can see that these two paths will cross. So will the player's path cross the ball's path? Yes. The paths will cross. The real question is, can you definitively tell whether the player and the ball's path are going to cross at exactly the same time? Well, no, we can't tell because we don't know at exactly what time these two things cross. So the answer to that is no. We can't tell exactly what time they both cross. So that should lead us into the next page. Okay, and I've gone ahead and filled out this table, and I have already filled out the equations. So let me kind of explain. Hopefully the table is something that you guys could figure out based upon the information. Every quarter of a second it said that the ball was moving 4 to the left and 3 down. So that's where we get the differences in the x and the differences in the y's for the blue one. The equations, now remember that these are each linear type equations, so they're both y equals mx plus b type equations, even though one of them's x, one of them's y, because remember that the independent variable here is t. So how did I get the -16? Well, if you look at it, remember that the time is based upon 1 second. So the time that it took to get from here to here, the x changed by 16. It went down 16 for every 1 second of time. And the initial point, which is like your y-intercept, was 32. And then for the y value, from 0 to 1 second, we went from 4 to -8, which is a change of -12. So we went down 12 for every 1 second of time, and the initial point was at 4. So that's how I came up with these two equations. And then for the green one, it's exactly the same idea, which I believe was the receiver's path. So it went from 26 to 14, which is a change of negative 12. And the y part went from negative 14 to 10, which is actually going up 4, with the initial point of 26 and negative 14 for my x and y respectively. So the question then becomes, when will the ball and the receiver be at the same x value? Well, what we can simply do is we can take the two x equations, negative 16t plus 32, and set that equal to the other x equation, negative 12t plus 26. This will tell us the time that the x values will be exactly the same. So solving this, let's see if I add 16t to both sides, that's going to give me 4t on the right. And then if I subtract 26, that's going to be, what, 32 minus 26 is 6. So t here is going to be 6 over 4, or 3/2. And then we can do exactly the same idea for the y. See when the y is going to be at the same place. Now we do know the paths will cross. The question is, are these times going to be exactly the same? So let's find out. So if we take the y's, negative 12t plus 4, and set that equal to the other y, which is 4t minus 14, let's see, I'll add 12t to both sides. You may be wondering why I keep going the other direction instead of moving the t's to the left. It's because I prefer to keep my variable positive if possible. And then I'll add 14 to both sides, so that's going to give me 18 equals 16t. Dividing both sides by 16 is 18 over 16, which reduces to, what is that, 9/8? So this one, as a decimal, is 1.5, and 9/8 is 1. I don't know. I think it's 1.0125. I could be wrong about that. It could be 125. Either way, they are not the same. I don't think that that's right, so I'm going to erase that. I was doing it without a calculator, so. But the times are definitely not the same. And it was actually asked in one of the other classes. I actually do prefer the fractions because those are exact answers, even though the times that were given were also exact answers. But if you happen to get something where it's like 5/3, it's better not to use the decimal approximation of 1.667, because that's just an approximation, it's not exact. So, will the ball and the receiver ever be at the same place at the same time? According to this, they will not. And you can clearly see here that the times when they are at the x and y locations do not match. All right. Alright, so the second part of this said the passing didn't work, but there's still time for one more play. So Navy's coaches have decided to try running the ball. The quarterback hands the ball to the running back at 32-4. Each quarter of a second, the running back runs 3 yards west and 1 yard south. Alright, so remember that each one of these things is occurring over a 0.25 seconds. So the 3 yards, in order to figure out how much it'll go in 1 second, is going to be, because it's only a quarter of a second here, we're going to multiply 3 times 4 to get the change of the x. And it's going west, which is a left direction, so that's a negative x value. So, x is going to be going left at 12t, and he started at 32. Whereas y says 1 yard south. Again, we have to multiply that 1 yard by 4, because that 1 yard is only every quarter of a second. To find out how much it goes in 1 second, we multiply that by 4, and south is a negative direction, so it's negative 4t, and he started at 4. So there's the running back. Yeah, there's the parametric equations for the running back. So the defender starts at the point 26, negative 14, and he's running to try and tackle the running back. Every quarter of a second, he runs 2.5 yards west and 0.5 yards north. So the two parametric equations for the defender, let's see, remember to multiply each one of the changes by 4. So his x direction is west, so it's also in the negative direction. So it would be, but multiplying 2.5 times 4 is negative 10. So negative 10t. And he started at 26 for x values. And then the y, let's see, he goes 0.5 north, so that's a positive direction. So that's going to be multiplied by 4. That'll be 2 in the positive direction, 2t, and he started at minus 14. So when will the two players have the same x coordinate? We'll do it like we did before. We will set the x's equal to each other. Let's do this in red. So we'll set the x's to equal to each other. So we get negative 12t plus 32 equals negative 10t plus 26. So I will add 12t to both sides. And that'll give me a 2t plus 26 on the right. We'll subtract 26 on both sides, so we get 6 equals 2t, or t equals 3. And then it wants to know when the two y coordinates will be the same. So let's set the y's equal to each other. Negative 4t plus 4 is going to be equal to 2t minus 14. So again, I'll add the 4t to both sides, and we'll get 6t minus 14 on the right. We're going to add 14 to both sides, so we get 18 equals 6t, and then dividing both sides by 6, we get that t equals 3. So the times are the same. The running back and the defender will meet at time t equals 3. So then it says, when will the Navy player get tackled? So we actually have to plug the t back into the running back's equation to figure out where he was. So if I plug t into the x for the running back, that's negative 12 times 3 plus 32. Now see, negative 12 times 3 is negative 36 plus 32 is negative 4. And then the y value, it's going to be negative 4 times 3 plus 4. Negative 4 times 3 is negative 12, plus 4 is negative 8. So according to this, they will meet and get tackled at the ordered pair negative 4, negative 8. Well, so according to this, he will get tackled, but if you go back all the way up to the top, negative 4, negative 8, let's see, negative 4, negative 8 is going to be someplace in the end zone. So the Navy player actually makes it all the way into the end zone before he gets tackled. So Navy wins the game. The tackle is in the end zone. All right, hopefully that will help you guys with the homework.